بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is the final exam of Math 111 term 221. Let us see the final and solve it together. This is the first question. Use the below graph of the function f to answer the following questions. Find the following limits if it exists. What is the limit of f of x when x approaches 1 from the right? So x approaches 1 means this is x and this is the value 1. So approach 1 from the right. When x approaches 1 from the right, what happens to f of x? F of x is the graph. So look to the graph. The graph is going down, down. As x approaches 1 from the right, the graph is going down. Where? To -3. So the limit is -3. What is the limit of f of x when x approaches 1 from the left? The minus up means you approach 1 from the left. So when you approach 1 from the left, where is the curve? When you hear the curve is here. When you hear the curve is here. And when you approach 1 from the left, the curve comes like this, and it approaches also this number, which is 1. So the limit of f of x when x approaches 1 from the left is 1. The limit from the right is not equal to the limit from the left. So the limit of f of x when x approaches 1 does not exist. If the two limits are equal from the right and from the left, then we have a limit when x approaches 1. Now, what is the limit when x approaches -infinity of f of x? Again, this is x. Concentrate on x. This is the x-axis. To the right, you go to infinity. To the left, you go to -infinity. So when x goes to -infinity in this direction, where is the curve? When you hear the curve is here. When you hear the curve is here. When you go like this, the curve goes like this. Okay? Where it becomes closer to this line, which is -2. So when x approaches -infinity, the function will approach the number -2. Y would be -2. So f of x is y, but this is x. Find the numbers at which the function f is not continuous. Well, find the numbers. When he says find the numbers, those are the x values. Okay? X values at which the function is not continuous. You see the function, this part of the function is continuous, but at this number, at -3, there is discontinuity. There is the graph. The graph is discontinuous here. And also at 1, okay, the graph is discontinuous here. Okay? But elsewhere, the graph is continuous. So you can say -3 and 1. So the numbers at which the function is not continuous, -3 and 1. Find the numbers at which the function is not differentiable. Well, if it is not continuous, then it is not differentiable. So immediately you put -3 and 1. Then the function could be continuous, but not differentiable, where when there is a corner or there is a vertical tangent, you can see that there is a corner here in the graph. So here at 3, the function is continuous, but it is not differentiable because there is no unique slope, there is no unique tangent line you can draw here. So at 3, the function is not differentiable, but it is continuous. Find the vertical asymptotes, the equations of the vertical asymptotes. Well, vertical asymptotes are vertical lines, like this line, in which the graph becomes closer to this line. So when x approaches -3 from the right or from the left, the graph becomes very close to the line x equals -3. So the line x equals -3 is a vertical asymptote. This is the definition of the vertical asymptote. There is no other case here. The graph is not going to infinity or negative infinity, except here at -3. This is not going to negative infinity. It stops at -3. If this continues, okay, then this line could be considered as a vertical asymptote, but in this case, it is not. It stopped. So there is only one vertical asymptote. What about horizontal asymptotes? Horizontal asymptotes are also horizontal lines, which the graph becomes closer when x goes to a negative infinity or infinity. So when x goes to negative infinity, we have seen that the graph comes closer to this line, and the equation of this line is y equals -2, because y here, this is a value of y. Okay? What about when x goes to infinity? What happens when x goes to infinity? You see that the graph comes closer to this line. And what is the equation of this line, the x-axis? What is y here? Y is 0. So the equation of the x-axis is y equals to 0. So there are two horizontal asymptotes. On the interval 1 to 3, is the function increasing or decreasing? 1 to 3 are x values. So we need to concentrate here from 1 to 3 when x is 1 at this interval. From 1 to 3. Okay, where is the graph? The graph starts from here, it goes up to here. From 1 to 3, the graph goes like this. Is this increasing or decreasing? That's increasing. Always you test from left to right, not from right to left. On the interval 3 to infinity, is the function increasing or decreasing? Let us determine the interval. This is x, these are x values from 3 to infinity. While x runs from 3 to, where is your graph? Well, it starts from here and it goes like this. What about this one? Is it increasing or decreasing? It is decreasing, going down. Decreasing means going down from left to right. Increasing means going up. All right, question 2. Let f of x be this function. Find the absolute maximum and absolute minimum values, so y values of the function f on the interval 1, 2, 3. Well, we know that the absolute maximum is the highest point. The absolute minimum is the lowest point in this interval, 1, 2, 3. So the function could have an absolute maximum or absolute minimum, either at the end points of this interval or at the critical points, critical numbers of f. So we need to find the critical numbers of f. To find the critical numbers of the function, we find the derivative. Derivative of 3x to the power 4 is 12x to the power 3, we subtract 1, minus 3 times 4, that's 12x to the power 2, subtract 1 from the power, negative 2 times 12, that's 24x, subtract 1, and the derivative of 1 is 0. So this is f of I. When you put it equal to 0 and you solve it, the solutions of this equation would be the critical numbers. Well, I can divide by 12, and I can take x as a common factor. So I'll have x squared minus x minus 2 equals to 0. Of course, if the calculator is allowed, you can use the calculator modify 4 to solve this equation and find the zeros, the critical numbers. Now, if not, you can factor x squared minus x minus 2 into x minus 2 times x plus 1, negative 2x plus x is negative x, so that's fine. So the critical numbers are 0, 2, and negative 1. These are the zeros. Either x is 0 or x minus 2 is 0, means x equals 2, or x plus 1 is 0, means x equals negative 1. So these values are the critical numbers. But we have to consider the critical numbers inside this interval. Now, to find the absolute maximum and the absolute minimum, we put the x values at which we expect and there is absolute maximum or absolute minimum. What are the x values? The endpoints of the intervals are important, 1 and 3, and any critical number inside this interval. 0 is not inside 1 to 3, because this is 1 here, outside. -1 is also outside. 2 is inside this interval, so we take it. So we deal only with 1, 2, and 3. There are 3 critical numbers, but we choose only 2 because it is the only critical number inside this interval. Now, how to evaluate f of each x value? F of 1, for example. Well, I need f of 1, so I go to the function f, and I replace x here by 1. 3 minus 4 minus 12 plus 1. You will find that the answer is negative 12. You can use your calculator also to replace x by 2. 3 times 2 to the power 4 minus 4 times 2 to the power 3, and so on. You will find that the answer is negative 31. And if you replace x by 3 in f, in the definition of f, you will find that f of 3 is 28. Now, to answer the question, look to the values of f of x, the values of the function. What is the greatest one? Well, 28. So here you have the absolute maximum. What is the absolute maximum? It is 28. So you can write it f of 3 equals 28, or you can just write it 28, which is less negative 12 or negative 31. Well, negative 31 is smaller than negative 12. So here we have absolute minimum. So what is the absolute minimum? It is f of 2, which is negative 31, or you can just say negative 31. Verify that this function satisfies the hypothesis of Rolle's theorem on the interval -1 to 3. Then find all numbers C that satisfy the condition of Rolle's theorem. Well, if you remember, Rolle's theorem have 3 conditions. The function has to be continuous inside this interval, has to be differentiable inside the open interval -1 to 3, and f of a equals f of b. So f of -1 has to be equal to f of 3. You see that this function is a polynomial. You can say that f is a polynomial, so it is continuous and differentiable on R. Okay? That's, you know, this fact about polynomials. Okay, now the conditions of the Rolle's theorem. What are the conditions? Well, f is, so we get from here that f is continuous on the closed interval AB, which is -1 and 3 in this question. And f is differentiable, means the derivative exists on the open interval -1 and 3, and you can find the derivative. We will find it now. And the final condition, what if check that f of 1 equals to f of 3. So replace x by -1, you will have 1 plus 2 plus 8, that's 11. And when you replace x by 3, you will have 3 squared 9 minus 6, that's 3 plus 8, that's also 11. So f of -1 equals f of 3 equals 11. The conditions of Rolle's theorem are satisfied. So we can say that this is 11. There exists C. Now, this is the conclusion of the Rolle's theorem. There exists C belongs to the interval, the open interval, -1 to 3, such that f prime of C is 0. That's the conclusion of the Rolle's theorem. So what is f prime? To find f prime of C, we find f prime of x. What is f prime of x? This is the function, so find the derivative. Derivative of x squared is 2x, derivative of 2x is 2, derivative of 8 is 0. This is f prime of x. So f prime of C, we replace x by c, and we have 2c minus 2. This should be equal to what? To 0. We solve this equation. So 2c equals 2. If you take 2 to the other side, divide by 2. So c is 1. Is this number between -1 and 3? Yes. So this is required C. This is the number C that satisfies the conclusion of the Rolle's theorem. Find the equation of the tangent line to this curve at the point. Well, the equation of the tangent line is given by y minus y0, which is, this is x0, y0, or you can call it a and f of a. So y minus f of 0, which is here y0, equals the derivative of y prime at x0, which is also 0, times what? X minus x0 or a, which is here 0. So in fact, the equation of the tangent line is y equals y prime of 0 times x. So all what we need to find is y prime of 0. To find y prime of 0, we find y prime of x first. So y prime, we have y equals x times cosine. How to find y prime? Well, we need to use the product rule. We have x times cosine. So the product rule says find the derivative of x first. What is the derivative of x? It's 1 times cosine plus x as it is times the derivative of cosine. What the derivative of cosine is negative sine x. You need parentheses. And now you need to find y prime at 0. Cosine 0 is 1. And here we have x, which is 0, times sine 0, negative sine 0. Sine 0 is also 0, so 0 times 0 is 0. So y prime 0 is 1. And the equation of the tangent line would be y equals y prime of 0, which is 1, times x. So we can say that y equals x is the equation of the tangent line. Find the vertical and horizontal asymptotes of this function. Well, this is a rational function, polynomial over polynomial. So to find the vertical asymptotes are the zeros of the denominator. We put the denominator equals to 0, and you can use mod 5.3 to solve it, or just by factoring. I have x and search for two numbers, their product is -3 and their sum is -2. So either x is 3 or x is -1. So the vertical asymptotes, the equations of the vertical asymptotes are x equals to 3, or if x plus 1 equals to 0, take 1 to the other side to -1. So there are two vertical asymptotes of this function. What about the horizontal asymptotes? Well, to find the horizontal asymptotes, we find the limit of f of x when x approaches positive and negative. Well, for rational functions here, positive, negative, infinity will give you the same answer, because in both cases, you take the highest power up, the term with the highest power, which is 5x squared, and the term with the highest power below, which is x squared. And now you can cancel x squared with x squared before taking the limit. And what would be the limit of 5 when x approaches positive or negative infinity? Well, there is no x here, so the answer would be 5. So the equation of the horizontal asymptote y equals to 5. Remember, horizontal asymptote is a horizontal line, so the equation is y equals, while the vertical asymptote is a vertical line, so the equation is x equals. Find the following limits if it exists. Okay, we start by replacing x by 0. E to the power 0 is 1. 1 minus 1 is 0. Sine 0 is 0. So you must be in the radial mode, okay, to find sine. Okay, so we have 0 over 0. So we can use L'Hopital's rule. L'Hopital's rule, we find the derivative of the numerator. Derivative of e to the power 2x is e to the power 2x times the derivative of 2x, which is 2, and the derivative of -1 is 0. Derivative of sine x is cosine x. Now, if you replace x by 0, e to the power 0 is 1 times 2 is 2, and cosine 0 is 1, so the limit is 2. And you can check by calculator, by replacing x by 0.001 or 0001 and find e to the power 2 times 0.001 minus 1 over sine 0.001, but e in the radian mode, and you'll find that the answer is very close to 2. Well, here I have a function raised to a function. So if I replace x by 0, I'll have 1 minus 0, which is 1. 1 over 0 is infinity because this is 0 plus. So when you replace 1 over 0 could be positive or negative infinity, but if you replace x by 0.01, for example, something close, very close to 0 from the right, you will find that 1 over 0.01 is positive, so the limit would be 1 to the power infinity, and this is one of the indeterminate forms. And if we have these three forms, 1 to the power infinity or infinity to the power 0 or 0 to the power 0, then we start by letting y equals 1 minus x to the power 1 over x, and then we apply len to both sides, so we can bring 1 over x down using the properties of the logarithmic function. So we can write it 1 over x times len of 1 minus x. And now we can find the limits of len y. And once we find the limit of len y, we will be able to find the limit of y itself. So what is the limit of len y? Well, len y is this one, 1 over x times this. And I will write it len 1 minus x over x, because when you multiply 1 over x times len, x will be down. Then you can write it like this in this form. If you replace x by 0, 1 minus 0 is 1, len 1 is 0 over 0. I have 0 over 0, so I can use the L'Hopital's rule. Well, the derivative of the denominator is 1, so I'm not going to write it. I just write the derivative of the numerator. What is the derivative of len? 1 over 1 minus x times the derivative of 1 minus x, which is negative 1. And now when I replace x by 0, I get negative 1 over 1 or negative 1. So what did I find? I found that len y goes to negative 1. The limit of len y is negative 1. Now how to find the limit of y? I raise both sides to the e. So e cancels with the len, and y would go to e to the power negative 1, or limit of y when x approaches 0 plus will be e to the power negative 1, and that's the final answer because this is y. So the limit is negative, e to the power negative 1. What about this limit, x squared e to the power negative x? Replaced by infinity. Infinity squared is infinity. E to the power negative infinity is 0. So we have infinity times 0. So what to do? We cannot use L'Hopital directly, but we have to bring one of the functions down. Well, e to the power negative x, you can bring it down easily as e to the power x, because the minus sign in the power takes e to the power x down. So now if you replace x by infinity, you will get infinity squared, which is infinity. E to the power infinity is infinity. So remember, e to the power infinity is infinity, but e to the power negative infinity is 0, and you can find that easily from the graph of the function ex. So now we can use L'Hopital's because we have infinity over infinity. Derivative of x squared is 2x. Derivative of e to the power x is the same function. If you replace x by infinity, you again get infinity over infinity. So I use L'Hopital's rule again. Derivative of 2x now is 2, while derivative of ex is ex. Now replace x by infinity, e to the power infinity is infinity, 2 to the power infinity is 0. So the limit is 0, and you can check your answer by replacing x by 1000, for example, because x goes to infinity. So 1000 squared times e to the power negative 1000, check the calculator and make sure that the answer is very close to 0. If you replace x by 3, I have 0 over 9 minus 0 over 0. You can use L'Hopital's or you can use factoring as you wish. So I'll use L'Hopital's here. Derivative of x minus 3 is 1. Derivative of x squared is 2x. Replace x by 3, 1 over 6. That's the answer. If you solve it by factoring, then you will have x minus 3. X minus 3 times x plus 3. This is the factored form of x squared minus 9. You can cancel these two. Still have 1 here and replace x by 3. So you will get 1 over 6. Find the derivative of the following functions. Show your work. Well, for the first part, I have product. So I'll use the product formula. So if prime of x would be derivative of x squared is 2x times tan inverse x plus x squared as it is times the derivative of tan inverse. Well, the derivative of tan inverse x is 1 over 1 plus x squared, and you can leave it like this, or you can write x squared out here. What is the derivative of this function? Well, I have parentheses raised to the power 6. So I'll use chain rule here. The derivative would be, the derivative of this parenthesis to the power 6 is 6 times whatever inside without any change to the power 5. So this is really the derivative of x to the power 6, 6x to the power 5. But this is not x, this is u to the power 6. So the derivative of u to the power 6 is 6 times u to the power 5, same u, times u prime. Now you need to multiply by the derivative of inside. Well, derivative of cosh is sinh. Derivative of 2x to the power 4 is 8x cubed, and derivative of 7 is 0. I have two functions added to each other. Derivative of lim is 1 over whatever inside the lim. This is x cubed plus 6x plus 5 times the derivative of what is inside. So it is 6x squared plus 6. This is the derivative of the first function. The derivative of sine x squared, I have to use the chain rule. Derivative of sine, the outer function is cosine of x squared. And now you multiply by the derivative of the inner function, which is x squared, which is 2x, and that's the final answer. Use implicit differentiation to find dy by dx. So immediately you find the derivative here, derived by x, you find the derivative with respect to x. So I have x squared times y cubed. This is a product, so let me use the product rule. Derivative of x squared is 2x times y cubed plus x squared as it is times. What is the derivative of y cubed? 3y squared times y prime, or dy by dx. Always when you find the derivative of y, it is y prime. Plus ex, there is no y here, so just write the derivative of ex. What about lim y? Derivative of lim y, 1 over y times y prime, which is, you can write it y prime over y. Now to find y prime, to solve this equation for y prime or dy by dx, I'll get rid of this y, so I multiply everything by y. So I'll have 2x y to the power 3 times y, which would be y to the power 4. Here I have 3, I write 3 first, then x squared. I have y squared, I will multiply by y, so it would be y cubed. And ex, I will multiply by y. And here I multiply by y, so the y would be cancelled. Now I need to solve it for y, so I'll bring the terms with y prime in one side. So 3x squared y cubed y prime, and let me bring y prime from the right hand side to the left hand side, and take the other two terms. These two terms have no y prime in them, so take them to the right hand side, and now take y prime as a common factor from the two terms in the left hand side. If you take y prime here, you left with 1. There must be, you must put 1 here, okay? Equals negative 2x y to the power 4 minus ex times y. And finally, y prime would be, to find y prime, just divide by this, the coefficient of y prime. So y prime would be whatever in the right hand side over the coefficient of y prime. That's the answer. For this function, find the following: the critical numbers. Well, we have seen how to find the critical numbers. We need to find the derivative. The derivative is 4x cubed minus 12x squared. And now we put it equal to 0 and find the critical numbers. You can divide by 4 and take x squared as a common factor. When you take x squared as a common factor, you have x minus 3. Because remember, I divided by 4. And I took x squared. To check, multiply again, x cubed minus 3x squared. So either x is 0 or x is 3. Either x squared is 0. This means that x is 0, or x minus 3 is 0. This means that x is 3. So the critical numbers are 0 and 3. The answer to part 1. Part 2, the intervals on which f is increasing or decreasing. Here I need to make a table for the signs of f prime. I need to know the signs of f prime, because we know that when f prime is positive, I'll have f would be increasing, and when f prime is negative, f would be decreasing. So I put the critical numbers. What are the critical numbers? I have 0 and 3, 2 critical numbers only, put them here, okay? And you check now the sign of f prime. Well, this is f prime. If you replace x by a number between 0 and 3, 1, for example, 4 minus 12, this would be negative. If you replace x in f prime by 4, for example, you will have 4 times 64 minus 12 times 16. This will give you a positive number. Okay? And if you replace x by negative 1, for example, you will have negative 4 here, negative 12. So it's in fact a negative number. Or you can notice that there is an x squared here. So the signs shouldn't change around the 0 of x squared, which is 0. And x minus 3, so the sign should change around 3. In fact, the sign of f prime depends on x minus 3, because x squared is always positive. So to the right of 3, it will be positive, because 4 minus 3 is positive, and to the left of 3 is negative. So you can figure out that these are the signs of f prime and by using different techniques. So here f is decreasing, f is decreasing, and here f is increasing. So intervals on which f is increasing and decreasing, well, the function is increasing from 3 to infinity only at this interval, but it is decreasing in 2 intervals. I can write from negative infinity to 0 union from 0 to 3, or just from negative infinity to 3, because the function is continuous at 3. It's continuous everywhere because it's a binomial, a polynomial. So I can write it like this. So that's decreasing from negative. The local maximum and minimum points of f. Well, there is no local maximum, but there is a local minimum here, because down, up, it's local minimum. So there is a local minimum where at 3, but he is asking what is the local minimum. So the local minimum is, you say, f of 3. And since we are going to sketch the graph, so I'll evaluate x by 3 in f, because I need to find f of 3. So I go to f and I replace x by 3. If you use the calculator and find 3 to the power 4 minus 4 times 27 plus 10, you will find that the answer is negative 17. So negative 17 is the local minimum. Number 4, the intervals on which f is concave up, concave down, and the inflection points. Well, concavity and inflection points, we found them from f double prime. So this is f prime, 4x cubed minus 12x squared. Let us find f double prime from here. Derivative of 4x cubed is 12x squared minus 24x. Now you put it equal to 0 and you find the difference. When you put it equal to 0, you can divide both sides by 12. And you can take x as a common factor. So you will have x times x minus 2. So there are two zeros of f double prime. We don't call them critical numbers. They are just zeros of f double prime. We need the signs of f double prime as we found the signs of f prime. So these two numbers, 0 and 2, we put them and we check the signs of f double prime. We know that if f double prime is positive, f would be concave up, the graph of f. If double prime is negative, f would be concave down. And when concavity changes, we will have inflection points. So choose one, for example, number between 0 and 2. 12 minus 24, that's negative. Number greater than 2, 4, for example. 12 times 16 minus 24 times 4, this is positive. And negative 1, negative 12 positive plus 24, that's positive. So these are the signs of f double prime. You can also use a trick or an information. If you have the degree 2, always degree 2, the sign of the function between the two zeros is opposite to sign of x squared. So x squared here, the coefficient is 12, it's positive. So between 0 and 2, it should be negative. The sign of f double prime should be negative, otherwise it's positive. So here, concave up, concave down, concave up. So we will have, let me tell him the concavity. Concavity up, where from negative infinity to 0, union from 2 to infinity, concave down from 0 to 2. And what about inflection points? There are two inflection points because concavity changes twice at 0. So I need to find f of 0. Well, this is f. If I replace x by 0, I'll have 10. So 0 and 10 is an inflection point. And 2 and f of 2, and let us find f of 2. Graph. So we need f of 2. If we replace x by 2, 2 to the power 4 minus 4 times 8 plus 10, we will find that the answer is negative 6. So these are all the information needed. And now let us sketch the graph of the function. Let us sketch the graph of the function. Okay, I'll put first the points that I have. Most important thing to me are the points. So what are the points? Well, I know that this is a local max. So 3 and negative 17. 17. This is a local minimum, sorry. So 3 and negative 17. I have to go negative to negative 17. I don't have enough space, so I'll use negative 2. So negative 2, 4, negative 6, negative 8, 10, 12, 14, 16. And now this would be negative 17. While here I can go one by one on the x-axis. So 1, 2, 3. So this is a 3. So this is the point 3 and 17. I have a local minimum here. A cup local minimum. So the function will be going up to the right of this point and to the local minimum. What else? What other points? I'd like to erase this because the answer is f of 3 negative 17. Okay. Other points, these are other points, the inflection points. Good. 0 and 10 is an inflection point. So 2, 4, 5, sorry, 2, 6, 8, 10. So this is 10. This is the point 0 and 10 inflection point. 2, negative 6. Well, I have 2, 2, 4, 6. This is the point 2 and 6. This point is an inflection point. So pay attention, I have 2 inflection points. So I know that the graph from here will go up and the concavity would be up. and then the concavity changes from here down, and then the concavity changes up, okay? But it doesn't go in directly, okay, like this. And here it goes up. The concavity is the same, do not change the concavity, always up. So let us check everything. Is everything fine? The concavity up from negative infinity to 0. Then from 0 to 2, it is down. And from 2 to infinity, it is up. Function is decreasing from negative infinity up to 3, the concavity from 3 on. So this is the graph of f of x. Everything is okay. Question 6. Find two positive numbers whose product is 49 and whose sum is, well, whose sum is minimum. This will give me a function that I need to minimize. So I need to minimize the sum. I'll call the sum S, the sum of the two numbers, two positive numbers. Let me call these two positive numbers x and y. So the sum, what is the sum of the two numbers? X plus y. This is the function I need to minimize. But I have two variables. I need one of them only. So I use the information in the question that says whose product is 49 to write y in terms of x. So product is 49. What is the meaning of that? What is the product of the two numbers? Two numbers x, y. What is their product? X times y. It says that the product is 49. So what would be y? If you solve this equation for y, it would be 49 over x. So S now would be equal to x plus, and y is 49 over x. So this is the function I need to find. I need to minimize. I need to find its absolute minimum. So to find the absolute minimum, I need to find the local minimum first. So I need to find the derivative. Derivative of x is 1. What is the derivative of 49 over x? Derivative of 49 is just a number, so I leave it. I find the derivative of 1 over x. Derivative of 1 over x is negative 1 over x squared. In fact, derivative of 49 over x is negative 49 over x squared. To find the critical numbers, I put the derivative equals to 0. So let me take this to the other side. So I'll have 49x squared equals 1. And then cross product, so x squared 49. So there are two possibilities here. X could be positive or negative 7. But he says two positive numbers. So x is 7 because two positive numbers. So the negative is rejected. Negative 7 is rejected. All right, so what are the two numbers? Now, at 7, this function has, let me check that at 7, this function has a local minimum. So let me check the signs of S prime. Well, the sum of two positive numbers cannot be negative. So I'll start from 0. It goes to infinity. Now, what is the critical number? It is 7. Choose a number greater than 7, 10, for example. 1 minus 49 over 100. 49 over 100 is less than 1, so it will be negative. If you choose 1, for example, 1 minus 49, it is negative. Sorry, it is positive here because 49 over 100 is less than 1. 1 minus something less than 1 is positive. So here the function is decreasing, here the function is increasing. So actually, I have a local minimum at x equals 7. And since it's the only local minimum in this interval, it would be an absolute minimum. So I have an absolute minimum at x equals 7. So the answer to the question, find two numbers the numbers are x is 7, and to find y, we find y from where? From here, because y is 49 over x. So if x is 7, y would be 49 for 7, and 7. So the two numbers are 7. Each side of a square is increasing at a rate of 0.8 meter per minute. So I have a square, and if I call the length of the side as x, then this side, any side, is increasing at a rate of 0.8. So this means that dx by dt is 0.8. So rate means derivative, okay? Derivative, and x is changing the side of the square if you call it x, so the derivative of x is 0.8. How fast is the area of the square is increasing? So fast or changing or rate means a by dt. He's asking about derivative of the area. How fast? We found that from the derivative. A by dt when the length of each side. So he needs the derivative when x, the length of the side, is 3. That's the question I need to find. Well, to find dA by dt, I need to find a formula for A. And A is the area of the square, and the area of the square is just x times x. And now to find the derivative, I have to derive this function with respect to x. So derivative of A with respect to x, sorry, I have to find derivative with respect to t, because everything here is changing with respect to t. So I find the derivative with respect to t. So derivative of A with respect to t would be equal to, what is the derivative of x squared? It is 2x times the derivative of x with respect to t, using the chain rule. To find the derivative of x squared, then you multiply by the derivative of x with respect to t. Well, he needs dA by dt. So I have x, it is 3, so 2 times 3, I have dx by dt in the question. And if you multiply this, you will find that by the calculator, you will find that the answer is 6 times 0.8, that's 4.8. So 4.8 watts, that's meter square per minute, because this is the area, so it's changing by meters, not by meter, like the length. So that's the answer. Show that this function is an even function. Well, the definition of the even function is even if we find that f of negative x is equal to f of x. And cosh x, the hyperbolic cosine, I know that the definition is e to the power x plus e to the power negative x over 2. So let me find f of negative x. What is f of negative x? It's cosh of negative x. And this means I replace x by negative x in this definition. So it would be e to the power negative x plus e to the power negative x over 2. And negative would be positive, and I can write it again, plus e to the power negative x over 2. And that's exactly cosh x, which is exactly f of x. So f of negative x equals to f of f to f of x. So f is even. This is the proof that f is even. Well, I stop here, and I hope that you enjoyed listening this video, and that solving this final exam helped